In this class, we will like to solve some of the systems in homogeneous. So, consider the problem. Solve x1 plus 2x3 minus 2x4 equal to 0. 2x1 minus x2 minus x4 equal to 0. x1 plus 2x3 minus x4 equal to 0. 4x1 minus x2 plus 3x3 minus x4 is equal to 0. Now, first of all, we represent the given system in the matrix form. So, the given system in matrix form is the quotient of x1 1, x2 is not there, so 0. Quotient of x3 2, quotient of x4 minus 2. In the second equation, quotient of x1 2, x2 minus 1, x3 not there, so 0, x4 minus 1. x1, in the third equation, quotient of x1 is 1, x2 not there, so 0, x3 quotient 2, x4 quotient minus 1. So in the last, quotient of x1 is 4, x2 is minus 1, x3 is 3, x4 is minus 1 into, so we wrote the quotient matrix A. Now next, the variable matrix x1, x2, x3, x4 are the variables. So it is denoted with x, and the right hand side all zeros. So here the constant column matrix is a 0. So it is a homogeneous system of equations. So we know that homogeneous system is always consistent. It will always have a 0 solution. That means x1 is equal to 0, x2 is equal to 0, x3 is equal to 0, x4 is equal to 0 is always a solution to this problem. Now we will find whether there is any other solution for this system or not. For this, we consider the quotient matrix A and find its rank. And you know, to find the rank of the matrix, the easy method is by converting the matrix into echelon form and finding its rank. Now, next, we consider the quotient matrix A. So, the quotient matrix A is equal to 1, 0, 2, minus 2, 2, minus 1, 0, minus 1, 1, 0, 2, minus 1, 4, minus 1, 3, minus 1. Okay. This is the quotient matrix. Now we will convert this quotient matrix into echelon form. So for this, we have to convert this 2 into 0, 1 into 0, 4 into 0. So for this, we apply R2 gives R2 minus 2R1, R3 gives R3 minus R1, R4 gives R4 minus 4R1. By applying these three operations on the quotient matrix, the quotient matrix will change into first row as it is 1, 0, 2, minus 2. Second row 0, minus 1, minus 4, 3. Third row 0, 0, 0, 1. Fourth row 0, minus 1, minus 5, 7. Okay, the next one. So here all the elements before the first diagonal elements are 0. Here 0, 0, 0. Next, in this one, next we have to make this one as a 0. For this, I am going to apply R4 gives R4 minus R2. So by applying R4 gives R4 minus R2, A will be similar to 1, 0, 2, minus 2. Second row as it is 0, minus 1, minus 4, 3. Third row as it is 0, 0, 0, 1. Fourth row 0, minus 1 minus of minus 1 plus 1 minus 1 plus 1 0, minus 5 minus of minus 4 minus 5 plus 4 which is equal to minus 1. Next 7 minus 3 is 4. So here now the system is 1 0 2 minus 2 0 1 minus 1 minus 4 3 0 0 0 1 0 0 minus 1 4. Next we will interchange the last two rows, that means R3 interchange with R4. R3 interchange with R4 to convert the quotient matrix into echelon form. So which is 1 0 2 minus 2, second row 0 minus 1 4 minus 4 3, the third row 0 0 minus 1 4, the last row 0 0 0 1. Observe the system is now in echelon form. Okay, 1 0 2 minus 2 0 minus 1 minus 4 3 0 0 minus 1 4 0 0 0 1. So here 0 rows if at all should be occupy the last rows. Here no 0 is present, so first condition is automatically satisfied. Second condition, the number of zeros before the first non-zero element should be in the increasing order. So in the first row, no zero elements before the first non-zero element. In the second row, 1 0. In the third row, 2 zeros. In the fourth row, 3 zeros. So the number of zeros are in the increasing order 1, 2, 3. Okay, so it is in the echelon form. So which is in echelon form. So rank is equal to the number of non-zero rows, in the echelon form of a matrix. So here the number of non-zero rows are 4. So rank of A is equal to 4. Coming to number of variables. Which is denoted with n. This is equal to, look at the system. The system has 4 variables x1, x2, x3, x4. So number of variables n is also equal to 4. Okay. So therefore rank of A is equal to n. The number of quotient matrix is equal to number of variables. Therefore the system has only 0 solution. Therefore the given system has only 0 solution. That means x1 equal to 0, x2 equal to 0, x3 is equal to 0, x4 is equal to 0. This is the only solution to the given system.